Hi, I'm Pat. Okay, so looks like we're doing some graphing in this problem, right? They've given us an f of x and a g of x that they want us to graph on the same xy plane and compare. And of course, it's all about these trigonometric functions, right? F of x in this case is just sine of x. G of x is 4 sine of x. And when you go to graph these trig functions, especially sine and cosine, the work that you definitely want to have a good handle on up front is this kind of scratch work where we're going to make sure we know what these 5 key points are for any period of the function. Okay, so you definitely should know, like with this sine of x in this case, you want to know what's the intercept, maximum, another intercept, a minimum, and then another intercept in terms of your basic sine graph. Okay, so what I'm talking about here is, if I even keep it color-coded, the first intercept for us in the period is going to be 0, 0. Okay, and that's because the sine graph starts right there in the origin, 0, 0. Okay? You might notice I did not label my x-axis here at all, so I might give you that advice, is to not put any values on these tick marks yet until you see what these 5 key points are. Okay? Then I'll come back and fill that out. So now back to what you should know, your basic function sine of x. One of the key points is that intercept, the first intercept, the starting point of the graph. The next key point is going to be the maximum. You should know that that occurs at a pi over 2 angle, so that's going to be my input, that'll be my x-coordinate, and the maximum value is 1. And as an ordered pair then, pi over 2, 1. Now let me head over here and graph that point even, and this is what I meant by like this tick mark. I didn't label it ahead of time because I wasn't sure if it was going to be pi over 2. And before you argue like, hey, we know it's always pi over 2 for this maximum. It's not true. It's true for the basic sine function, but for these other functions that you're going to be drawing, sometimes those x values shift left or right. Okay, so be careful. All right, let me move back to the key points that you should know. The next one would be the intercept, which occurs, another intercept, I should say, occurs at pi as the angle, or the input value now, the x-coordinate. And of course, if it's an intercept, your output is 0. Back over here, that's telling me that my next key point will have an x-coordinate of pi and a y-coordinate of 0. I just realized I talked so much about labeling this tick mark that I didn't plot the point, which was at pi over 2, 1. Pi over 2, 1, there it is. Okay, back to the key points. The next key point in your basic sine graph is a minimum at 3 pi over 2, -1. I'll plot that over here then when I get this as 3 pi over 2. I want to go down to a -1, which will be right about there. Call that 3 pi over 2 on the x-axis. And then last part of the key points in the first period of a sine graph would be another intercept at 2 pi, 0. So right there. I now know for sure I want to label this x value as 2 pi and plot the y value of 0. Okay. Now I was trying to describe how this is really key work on your part to get these key points, and then once you do, it's really just connecting the dots. And I'm sure you learned in this lesson that that's your basic shape of a sine graph. Okay, pretty good, I think. Now, let's apply our knowledge to this next function then, which is going to be a little bit different, a little bit more involved, but I really want to point this out. Definitely a point of these problems is they're trying to get you to see the relationship between these two functions. So look for how similar they are. In this sense, in this case, there's your sine of x, which is the same as your f of x. And the only difference is we're multiplying by 4. I know you know this. It's called the amplitude, right? And think of it this way then, is that amplitude, that value of 4, is taking whatever your outputs were from the f of x function, whatever your y values would be in the graph, and they're just multiplying them by 4. Okay? So when the x values are the same, the y values are only going to differ by a factor of 4. I'm going to use that knowledge over here in my work on the 5 key points by using the same x value of 0, comma, and then multiply that y value by 4. And the y value in this case is 0, and of course 0 times 4 is 0. But it'll be important to see what we just did in these next couple of points is to keep the x coordinate the same, take the y coordinate and multiply by 4. Pi over 2, comma 4. Pi, 4 times 0, there's another one of our zeros. 3 pi over 2, comma negative 4. And finally, 2 pi, comma 4 times 0 again, 0. Now back over to the graph. Let's plot those exact points. So I do have 0, 0 again. And then pi over 2, comma 4. It's going to be up there. Pi, comma 0. I've got this point again. 3 pi over 2, comma negative 4. Down there. And then 2 pi, comma 0, which hits that same point. And to connect the dots, I'm going to go up a lot higher than before, down through that point, a lot lower than before, and back to that point. Of course, it continues forever, right? But we're just looking at that one period. I kind of started with this, is that what you're looking for then is the relationship between these two graphs. See how they both look like that sinusoidal curve, it's called, but the green one is stretched a lot more than the red one. Okay? And that's because of the amplitude. All right, these take some practice. I know you'll do it. Make sure you do your homework.